The third law of radical talks about the power law, which is almost similar to the power law of exponents. It states here that if we have an nth root of a radicand, which is expressed as an exponentiation, a to the power of m, we can simply move out the exponent of a radicand and make it the exponent of the entire radical expression of the same index n. Let us show that from here, this is equal to that. Of course, a here is our radicand, or in the context of our left hand side, this is actually a base of an exponentiation. So they are just the same, radicand, or again the base of an exponentiation. And of course, n and m are your n is your index and m is the exponent of your radicand for your left hand side, but it is also an exponent of your expression on the right hand side. So let's start by writing this first here, nth root of a to the power of m. Okay, with this in mind, take note that there is a transformation of any radical expression into an equivalent expression with fractional exponent. This could be written as your a would be your base now. The exponent m here of your radicand becomes the numerator of the fractional exponent, and your index becomes its denominator. Okay, before we proceed, again, let's review. For this expression where n is your index and m is your is the exponent of your radicand, it could be written as an expression with a fractional exponent with the same base of your radicand. And now, the exponent of your radicand is the numerator, and your index becomes your denominator. Now from here, we can actually rewrite this, if you would like to, just because our goal is to reach here, we can rewrite the exponent as a product of 1 over n times m. Okay? Because m, we have here, that's just m times 1, so we can factor m and you have 1 over n. With that, we can now regroup this expression, let's say using the power law of exponents, that when do we get a product of exponents? That only will happen if we have an exponentiation raised to another exponent. So again, from here, we can simply group these two to have an exponentiation a to the power of 1 over n, and your m becomes an exterior, or your outer exponent in the power law of exponents. Now, let us return to our radical expression. We have a fractional exponent. Take out earlier that the denominator becomes your index. So since we have the same denominator n, that becomes your index of your radicand, or now your base a, with the power of your numerator 1. And this is still subjected to an outer exponent of m. So basically, removing the exponent of 1, you will have here nth root of a raised to m. This is actually what our power law states. In short, the nth root of a radicand which is already an exponentiation is just equal to taking out the exponent of the radicand. You have here nth root of a raised to m. And by the way, what's the purpose of this law? The purpose of this law is that, of course, we are trying to simplify. And what if m here is too large? Let's say this is greater than 5, 6, 7, 8, 9, 10. So it's difficult for us to take, not difficult, but we can get the value of the radicand, but it's difficult for us to simplify it with any index because this is now too large. So with that, move out the exponent, simply take the nth root of whatever the radicand is, then you take the that to the m power. So this is another session for properties, laws, and theorems. Please subscribe now.